Greetings everyone. So this was supposed to be an online class. Since now we were unable to take out that class, I'm taking the class now. So before we start we will be working mainly in this session. We will be working mainly on the centroid calculations once again, and then the centroid calculation for the composite areas. Okay. So let me start with the basic ones which we have already dealt with. If you recall, finding out the location of the centroid of a triangle of base B and height h from the base. So what you are going to do is we are sorry. So what we are doing is we have considered a small strip and the elemental strip, and for this I am trying to find out the area of it. Okay, I am trying to find out the area for this elemental strip. It is representing a similar triangle principle. So using that similar triangle principle, we are trying to find out the required details, right? Okay, so the thickness of it, we are considering it as dy and width as b1. You are considering the area of that, which is going to be dA is nothing but b1 multiplied with dy, and that b1 we are trying to convert it in terms of the another these things. Okay, using the similar triangle principles, we try to find this. Okay, so what we will be working on is, yeah. So what we will be working on is you got the elemental area of the element. So and then I am trying to find out the first moment. First moment is nothing but integral y into dA. Okay, with respect to this, so the perpendicular distance is y. So integral y into dA, y and dA you got here. దీని మొత్తాన్ని కూడా ఇంటిగ్రేషన్ చేస్తాను. That is coming out to be bh square divided by 6. That bh square divided by 6 divided by area of the total triangle, which is going to be half into b into h. So that gives me the location of the centroid, which is y is equals to h by 3 from the base. Similarly, we try to deal with the centroid calculation for rectangle, centroid calculation for right angled triangle also. Hope you remember when we discussed about these two things. I did the calculation for the rectangle part, if you remember. So the same thing is what we will be following, nothing more, nothing less. Now finding out the centroid for the semicircle, you have taken out a small elemental area here. Whether you are taking an elemental area, whether you are taking the strip, it all depends on your mathematical skills. The more complex you want to make it happen, the more complex shape, the more complex things you can consider. Okay. So in this case, what has happened is a small elemental part is taken out, which is having the area of dA. So that is coming to be dr into r d theta. Okay. So this is representing like a sector. The radius of this sector is r. So this length is going to be, let me zoom in onto that location for a while. So this dimension, it is going to be r into d theta. Okay. So when I'm trying to find out the total area of it, it is going to be r d theta. All right. R d theta multiplied with r d theta multiplied with dr. Okay. So that is going to give me the total area of it. Now I know the area, the distance is going to be r, and I need to find out the centroid of the semicircle from the diameter. So that is going to give me r sine theta as the value. That is the x value that I will be taking out. Okay, right. So the moment about the diametrical axis is going to become r d theta dr. This is the area of the element multiplied with r sine theta. So this is the value that I have got. Okavela, by any chance, if you are not considering, see, in this problem they have not given anything. If I am going to take out this portion as my reference axis y, so this is not going to be the reference axis now. In that case also you can follow it with the same procedure, but you will be calculating x bar, the centroidal location for x and centroidal location for y. So from the symmetry, what you can say is x bar is going to be located at a distance of r. Y bar is what we are going to calculate using this procedure. అంటే depending upon where your reference axis is going to lie, this entire calculation is going to get varied. You should be able to understand it by now. Okay. So now let me use the laser pointer for this. So I got the first moment of area. Now you need to apply the integration so that you can go for the entire part. So since you have two unknowns, these two are discrete and independent. Discrete and independent. So that is why you can apply the integration separately for both of them. And this is the first moment of the area about the diametrical axis that you are going to get. So since it is a semicircle, you are going to get it as 0 to pi and 0 to r. R value is small r value is going to be varying from 0 to capital R, and theta value is going to be varying from 0 to 2 pi. Sorry, 0 to pi. So once you perform the integration part, you are going to get the first moment of area. Then once you get the first moment of area, the area of semicircle is known to us, pi r square divided by 2. Okay. So y bar is nothing but moment of the area divided by the total area, that gives me the location of the centroidal disk from the diametrical end. From the diametrical end. Okay. ఎందుకు diametrical end అని అంటే it is taken at the bottom side. So that is the reason. The next one is this part also we have seen a circular sector. So same is the case here also. If you want it to be, you know, the centroidal axis, if you are going to take them at these locations, your mathematics is going to become a little bit complicated. Ante antak minchi inkem undadu. Where you are taking out your origin and reference axis, you will be calculating the moment from here. It is not going to be simply x is not going to be 2/3 of r cos theta. It is not going to be 2/3 of r multiplied with cos theta, but it is going to be some other value. అంతే, ఇంకేం ఉండదు. సో దీనికి ప్లస్ ప్లస్ దేర్ ఈస్ గోయింగ్ టు బి సమ్ అదర్ థింగ్ దట్ యు ఆర్ గోయింగ్ టు గెట్, అండ్ దాన్ని బేస్ చేసుకొని ఎవ్రీథింగ్ ఎల్స్ ఈస్ గోయింగ్ టు గెట్ చేంజ్డ్ ఇన్ దిస్. You should be able to understand that. Okay. Now x is equals to 2/3 of r cos theta. Area of the elemental portion is going to be dA is equals to half r square d theta, because it is representing a triangular portion. This is the total area of the sector that you are going to get. And the first moment of area about the y-axis is what we are taking. Remember, it is symmetrical about x-axis, so I need to find out the x bar. Symmetrical about x-axis, so I need to find out with respect to the x bar. If it is symmetrical about y-axis, I need to find out the y bar. Now, the moment the angle is going to be varying from minus alpha to plus alpha, 2/3 of r cos theta, this is the x value that you got, multiplied with the area of the element is going to be half r square d theta, and this is the first moment of area that you are getting. Then comes the next part, which is x bar is equals to moment of the area about y-axis divided by the total area, that gives me the x bar value. Okay, so this is all about the things that we have already done, and I am pausing in the video. Wherever you want to take a snap, you can pause the video and you can make note of it. Similarly, for the quadrant portion also, the same strip is taken, the sectoral portion, like we did for the previous part. No, if you are interested in, if you are going to say that no, sir, we are going to use the same part which I have done in the semicircular part. So you can also take out a small area like this and perform the same process again. Then also you are going to get the same answer. The only thing is your calculations are going to get changed a little bit. That's it. So here what you are doing is you are considering it a small elemental area that is looking like a triangle. So you are going to find out its area of the that elemental strip, that gives me the half into r square into d theta, and the first moment of area is going to be a into x bar, that is equals to so from this what I'm going to get is ax bar is equals to integral x into dA. Total area value is known to us, x bar is known to us, sorry, x bar is the one which we are trying to find out. Then integral over 0 to pi by 2, 2/3 of r cos theta multiplied with dA value, which is 1 by 2 r square d theta. applying the integration part and performing the all the other things, you are going to get it as x bar is equals to 4r by 3 pi. Performing the same thing on to the other end, you are going to get the same part. So this is all for the x bar. Same, only your calculations are going to change a little bit. You are going to get the y bar value also as 4r by 3 pi. And so this is all about how you are trying to find out the centroid for basic areas using the first principles. First principles using the integration, you can give any name, but that is the way that you will be following further. Okay. Now, going to the next part. So these are all the things that you are supposed to make note. Please do understand where your reference axes are. Based on the location of your reference axis, these x and y bars locations are going to change. Now, there is a small point that I wanted to highlight here. If you are going to draw a set of axes, okay, if you are trying to draw a set of reference axes that are going to be considered origin at the centroid. So these axis is what you call with the name of centroidal axis. We are going to give the name as xg or yg or xc or yc. So the names that we will be giving are xg and then yg. Okay, or else xc and yc. So these are the values. So these axes are called as the centroidal axis, and these centroidal axes are going to be very much helpful to us in the big calculations. Okay, the next part. Now this problem also we have seen. So you have the area, and you are asked to find out where does this thing is going to lie. Okay, the location of the centroid. So first you will be finding out what are the limits for x and y. Okay, for that what you are doing is you are converting it into the y in terms of x and x in terms of y. So y square is equals to 25x. That gives me y is equals to 5 root x. If I want to find out the x value, it is going to be y square divided by 25. And here what I am doing is I have taken out a small elemental strip in the vertical direction, and the area that is going to be y into dx, integration over the area whose limits are going to be 0 to 4. So that gives me the value of the total area. So like I have mentioned how you have got the y and x value. So once you are going to solve them, you will get the relation between x and y. That's it. Now considering the infinitesimal area and trying to find out the moment about the y-axis, it is going to be x multiplied with dA, x multiplied with dA. So that gives me integral 0 to 4 x into y dx. Substituting all that, you are going to get the relation for that my value. Similarly, performing for mx. So here it is going to be a little bit change. Why? Because you are considering the x, the location of it is going to be from the origin. So this is the x value that you are going to take, and this is the y value that you are going to take. And here the area dA is going to be 4 minus x into dy, where x is nothing but y square divided by 25. So 4 minus y square divided by 25 into dy is going to be the area multiplied with y. So దాన్ని లోపలికి తీసుకొని వెళ్తాము. You are going to apply the integration part and apply the limits. You are going to get the moment value. Location of the centroid is nothing but my divided by a and mx divided by a. That gives me the location of the centroidal coordinates. Okay. Similarly, the another example which I wanted to highlight in this class, the one which I didn't took the liberty of discussing in your class. So ఇక్కడ కూడా ఏమవుతుంది అని అంటే you are given one curve like this, y square is equals to 3x, and there is another curve y is equals to x square. రెండు curves ఉన్నాయి. Using the first moment of area is what you need to find out, and then they are asking us to find out the centroidal locations, centroidal coordinates for the shaded zone. Okay, centroidal coordinates for this shaded zone. You can make note and pause the video. I'm going to just take a pause here. Okay. So using this same principle, first you need to find out the limits. Mana observation prakaram, this is going to be 0, comma 0, this corner. I need to find out what are these values. So what the easiest way that I can do is y is equals to x square. So this x square I'm going to keep it here. So that gives me what? X to the power of 4 is equals to 3x. Hope I am right. So that gives me the another value of what is the value of x. So it is going to be x cube is equals to 3. X is equals to 3 to the power of 1 by 3. And once I'm going to substitute it here, I'm going to get the value of y is going to be 3 to the power of 2 by 3. So 3 to the power of 1 by 3 and 3 to the power of 2 by 3 are the two values that I'm going to get. That's the calculation that I have provided you here. Y square is equals to 3x. Substitute it in here. X square whole square is equals to 3x. X cube is equals to 3. X is equals to 3 to the power of 1 by 3. And substituting it in the one of the equations, you will get y is equals to x square. Y is equals to 3 to the power of 2 by 3. So one limit is going to be 0, comma 0. The other limit it is going to be 3 to the power of 1 by 3 and 3 to the power of 2 by 3. And how is it found? It is found by two curves. Y square is equals to 3x and y is equals to x square. ఇందులో ఏది ఏది అనేది you need to understand. So y square is equals to 3x is of convex shape and y is equals to x square is of concave shape. So in between the area is what you need to identify. అంటే ఏంటి? If I am going to draw a curve, so ఇలాంటి ఒక curve ఉంది and this is the area under it, and there is another curve of this much shape, there is an area under it. What we need to do is you need to minus out these two. You need to minus out these two so that you should be able to get this area. You should be able to get this area. Okay. In order to get this area, you need to minus out these 1 and 2. So from there itself, your entire calculations are going to change. So I'm just giving a pause here. You can pause the video and make note of this. All right. The next one. So the shaded area can be taken in this form. Limits are same for both. Limits are same for both. ఒకటే ఏంటనంటే ఒకటి పాజిటివ్ ఒకటి మైనస్. So considering that infinitesimal area, you are taking out a small strip there, taking the small strip and you are trying to find out what is going to be the value for that. So integral y to the power 0 to 3 to the power of 1 by 3 y into dx, and using the same thing, you are going to find out the required values there. The total area can be found out. Okay. Similarly, finding out the my value. So with respect to y axis, x multiplied with dA over the area. So there are two parts in here. Okatemo positive value and this one is the negative value. So we are going to apply both of them, and this is what the my is going to be in total. Now using the same strip, if I try to find out the mx value, that is going to be integral y dx multiplied with y divided by 2, because the height y gabatti y divided by 2 in both the cases. So that gives me 1 by 2 common తీస్తే integral y square dx. So integral 0 to 3 to the power of 1 by 3 3x dx, and y square is equals to 3x కాబట్టి then y is equals to x square. So this gives me x to the power of 4 dx. So this value we are trying to minus it out. This value we are trying to minus it out. So that gives me the value as 0.94. Now you may tell me, sir, ilane enduku cheyali? Why should I follow the same method? I'm not going to follow with this strip. Instead, I'm going to use up the horizontal strip. Yes, you can. So if you're going to take out the horizontal strip and follow the same method like we did for the previous problem, that also is going to result in the similar value. If you're going to round it off to 2 digits after the decimal, you're going to get it as 0.94. Here you got the value as 0.936. That's the only change that you have here. So once you get the moments, xc is equals to my by a, yc is equals to mx by a. That gives me the required values of this thing. Just for your information, first moment of the area is going to be of unit to the power of 3, because area multiplied with moment arm. I repeat, area multiplied with moment arm. Area multiplied with moment arm. So that is why you are going to get the units as unit to the power of 3. లేదా meter cube or cube or centimeter cube. You can give any name. Okay. So I'm just giving a pause in this slide. You can pause the video and make note. This slide, you can pause the video and make note. This slide, you can pause the video and make. So one way is you can use up the same strip and do the calculation. Otherwise, you can use up the horizontal strip. You can create another strip of horizontal direction and do the problem. Okay. Now the centroidal coordinates, that is what I was mentioning to you. So any axis which is passing through the centroid of an area are what called as the centroidal axis of that area, and those corresponding coordinates are also called as the centroidal coordinates. So since it is the axis of symmetry, in the case of axis of symmetry, first moment of area is going to become 0. Enduku anante it is dividing the entire area into the half portion. So if you are looking at this entire shape, at the axis of symmetry, on the left side whatever the area is there, on the right side also same area will be provided. That's what the symmetry means. Now because of this symmetrical portion, what is going to happen is, when I am considering a small area here, the moment of this area about this portion is going to be same as the moment of this area about this portion. అంటే ఇదేమో నెగటివ్ మూమెంట్ అవుతుంది, ఇదేమో పాజిటివ్ మూమెంట్ అవుతుంది. a divided by 2 multiplied with x, a divided by 2 multiplied with minus x. అంటే ఇది యాంటీ క్లాక్ వైజ్ గా minus x, this is going to be positive x. So a multiplied with x plus a multiplied with minus x. So what is it that I am going to get? I am going to get it as 0. So that's what we are trying to look at. And it cannot be the same for all the other things. Composite areas, this part also we have seen, we try to look at this problem. Okay. This is where we stopped in the previous class, if you recall. So the beginning of new year, we are taking out the new class now. Hope you have made note of the problem. Okay. Now the reference axis is what you need to first start with. So in this the general terminology is you need to keep your reference axis at the leftmost and at the rightmost, sorry, bottommost. ఒకవేళ వాళ్ళ క్వశ్చన్లో ఇస్తే that is going to be another case. If they have given it in the question, you need to follow it. No, there is no other go. But here you need to follow this method only. Okay. Now, once I got this value, the next step that I need to do is what are the areas that needs to be considered. I gave you one table. Please do make sure that you remember that table. Okay. So what we will be working on is, so from my observation I can say that indulo there is a rectangle, big rectangle, and from that big rectangle one semicircular portion and one small rectangle portions are being removed. Okay. So this is what we are doing. So first one, the small semicircle which is being removed. So this centroid is going to be lying at a height of 4r by 3 pi from here. That part we are already aware. And due to symmetry, it will be lying at the center. That part also we know. So it is going to be lying somewhere here. So r is going to be 20. So I am going to find out this 4r by 3 pi. Its location from this axis is what I am going to find out, which is going to be, this value is 7. Okay, the centroidal value is 7 plus 20. So x1 bar is going to be 27, and y1 bar is going to be, total height is 40. 40 minus 8.488, which is 4r by 3 pi. 40 minus 4r by 3 pi, that gives me this value. So these are the coordinates of the centroid of this semicircular portion with respect to the reference axis that I have set. Okay. Similarly, the next one, rectangles, the small rectangle. So what is the principle that you are following? First, you are setting out the reference axis. Then you are trying to locate where does the centroids of individual areas are being located. So individual area is for like this for this small rectangle, height lo half, width lo half. So uh, x2 bar is going to be this 47 plus 35 divided by 2, that gives me 64.5, and y bar is going to be 13 divided by 2 directly. Now I know the x2 bar and y2 bar. I know the a2 value. The negative symbol why we are using? Previously also have used the negative symbol. Why am I using it? Because we are removing out these two areas. Now comes the third one, which is the total area. So the total area is of what is that? 82 mm. 47 plus 35, which is going to be 82 mm in width. So divided by 2, that gives me 41 mm from the origin. Okay. Then total height of that big rectangle is going to be 40 mm. So that is 20 mm, and the area is going to be 82 multiplied with 40. Okay. So I have got all the three things. What we will be doing is we are going to keep all this information in a table, and this is how we are getting it. Area in millimeters, xi bar, area ai into xi bar. So you are multiplying mm square multiplied with mm. So that is why you are getting mm to the power of 3. Yi bar, ai into yi bar. Summation of these divided by the total area, you are going to get the x bar and y bar values, nothing else. This is the moment with respect to y axis. This is moment with respect to x axis. This is the total area. Okay. So once you get this table done, you just need to calculate the summation values. From there, you are going to get the location of these two centroids. Sorry, location of the centroidal axis. All right. Okay. So that is all about this problem. See, this is what you will be doing it for the composite areas. This table you need to memorize. This table you need to understand. Writing down this heading is not a big task, but in order to fill out these details, you need to do this much of brain work. Brain lo ఇంత వర్క్ చేస్తేనే it is going to be easy. Otherwise, it is not going to be much easier task for you. Same is the case for this. So let me remove the written up part. Let me remove the written up part. Just a moment. Yeah. Okay. So you have the entire area located for your reference. Now, what is happening here? They're asking you to find out the centroid of the shaded area, and there is a big rectangle of 200 mm by. What are the dimensions of it? 200 mm by 140 mm is the big rectangle. అందులో నుంచి మూడు ఏరియాలని రిమూవ్ చేశారు. ఏంటేంటి అవి? There is one uh, right angle triangle, there is one circle, and there is one circle, and then there is a small rectangle. So దీనికి centroid location is going to be somewhere here, where this height is going to be 1/3 and this height is going to be 1/3. This distance is going to be 1/3. This distance is going to be 1/3. So E value is easy for me, which is 30 divided by 3. This value is also going to be easy for me, but I need to find out what is that value. So this total is 140. అందులో ఇది 60. So what is going to be this height? 80. So the centroid is going to be located at a height of 1/3 from the base. So this is my base of the triangle. ఇక్కడ నుంచి 1/3 distance లో it is located. But I need to know the distance from this reference axis. This is my reference axis, x. So 140 minus 80 divided by 3 is what I am going to do. Next, for this circle, which is having the radius of 50 mm, It is directly located there, so I don't need to do much calculation in this. I don't need to do much calculation in this. So ఇది minus direct చేసేయచ్చు. Next you have this part, rectangular portion, which is of 40 mm is its width. Its width is 40 mm and its height is 60 mm. So 40 divided by 2 and 60 divided by 2. Here is where it is going to be, where I have placed the cursor. But what I need to do is, I need to find out its location with respect to the x and y axis. సో అప్పుడు నేను ఏం చేయాలి, ఈ టోటల్ 14 తీసేస్తే ఇది మొత్తం ఎంత అవుతుంది, 160. 160 plus 40 divided by 2, and then from here 80 plus 60 divided by 2. Okay, so that's what we are going to do here. Correct. So 200 minus 40 divided by 2, 80 plus 60 divided by 2. Center circle is located in the center, so that is why we didn't do anything here. Okay, a2 multiplied with xi bar and a2 multiplied with yi bar. I believe you can have a look at this table itself. ఈ మూడు కూడా మనం రిమూవ్ చేస్తున్నాం, so these three values are negatives and this is the positive value. That's it. Whenever you are dealing with the centroid, you need to draw this table and you need to practice in this manner. That way only you will be able to survive. Okay, you can pause the video here and make note. I am going to intentionally leave out some spaces. I will be checking your notes. I want you to make note, pause the video and make note. This is going to be your practice. This way only you will be able to solve all these problems easily. So the total area you are going to get, okay, total area you are going to get, which is going to be this value, summation of the ai into xi bar and ai into yi bar. So వీటన్నింటిని యాడ్ చేస్తారు, వీటన్నింటిని యాడ్ చేస్తారు. Whatever the values that you are going to get them divided by the area. So that gives you the xc and yc values, or x bar and y bar values. Similarly, so that's what you have seen here. That's what you are seeing here. Okay. Same is the case for this one also. So first let me delete these write-ups so that you will be able to understand it thoroughly, more thoroughly. So I'm removing this colors. I'm removing the write-ups. First I have removed the write-ups and colors. So this is what they have given here. Word question law, they have already fixed out this reference axis. So there is no other go that you need to follow. What is in reference axis na మనం follow అవ్వాలి. So if you look closely, it is in the second quadrant. So x values are going to be minus, y values are going to be positives. Okay, that is point number 1 to be noted. Next one, how is it made up of? Three different areas. Correct? Three different areas. All right. So it is made up of three different areas. You can see the colors. One rectangle, which is of 100 mm by 50 mm. Then there is a triangle, 50 mm height and 50 mm width. And then there is a semicircle who's having the radius of 25 mm. So obviously its height is also going to be 50 mm diametrical length. So you got three areas. I'm going to calculate those three areas. That's it. A1 rectangle. Okay. And where is its centroid is going to be lying? 100 divided by 2. So it is in the negative direction. So minus 100 divided by 2. Y bar is going to be 50 divided by 2. So y bar is nothing but 50 divided by 2 for that y1. Then you have the semicircular portion for the A2. So where is it located? మనకు తెలిసింది ఏంటంటే its centroid is going to be located somewhere here, and this distance is going to be 4r by 3 pi. Okay, so from here it is going to be located at a distance of 4r by 3 pi. That part we know, but where my reference axis is here. My reference axis is here, so I need to find out this distance in between. So I need to do what? 100 plus 4r divided by 3 pi. And what is going to be the y 2 bar, it is going to be r by 2. Sorry, the diameter divided by 2, which is 25. Then the third one, which is going to be the triangle. So it is మనకి వాడిచ్చిన బెనిఫిట్ ఏంటి అని అంటే దే హ్యావ్ సెడ్ దట్ ఇట్ ఈస్ ఎ సిమెట్రికల్ యాక్సెస్ అని చెప్పి ఒకటి ఆల్రెడీ ఇక్కడ డ్రా చేశాడు. సో దట్ ఈస్ గోయింగ్ టు బి an asset to us. So centroid is located on this line. Okay, centroid is located on this line. But how much distance from the base? It is located at a distance of 50 divided by 3 from the base, because its height is 50. 50 divided by 3 from the base. But I need to find out its reference line, the reference distance from here. From here. So total is going to be 50 plus 50 divided by 3. Okay. Area x bar, x1 bar, y1 bar, x2 bar, y2 bar, x3 bar, y3 bar. Ante, there is not going to be a big task in this. It is going to be very much easier. So you are going to make a table out of it. You are going to draw it in the form of a table, and doing so, you are going to get it in this format. All right. Okay. So please do make sure that you are making note, pausing at the right moment. I'm giving pause in between intentionally. This video is going to long around 1.5 hours or 1 hour 45 minutes. So once you get all of these things done, add up these. And ఇక్కడ మనకు 3 areas are there. So all the 3 areas you will be adding up, and here 3 areas are there. 3 multiplications, you are going to add up these 3. Like I have mentioned, since x bar here is negative, you are going to get the x bar value in the form of negative. That's it, nothing else. And considering this as 0, 0, you are going to find out the coordinates of the centroid. Since the entire area is located towards the left side of y-axis, you are expected to get the x bar value as negative. So once you have this, so total area is known. Total area, summation of a bar into xi bar. So that value divided by the total area, and this value divided by the total area, that gives you the xc and yc values. I am intentionally leaving out these spaces. I am expecting that you are making note properly at the right moments. Please do not think that I will not be checking your answers, or I will not be looking at your notes. I will be checking out your notes when it is time, and you do not know when. Now, coming to the next problem, triangle, below it you have a semicircle. So you can see this CD, which is the axis of symmetry. I don't need to do much work in this, correct? I don't need to do much work in this. I just need to simply apply this principle. So if I am taking the reference axis in this format, it is going to be helpful to me. Okay. I am considering the reference axis in this format, and this is how it is going to be beneficial to me. This is going to be beneficial to me. No, sir, I do not want to follow that, but I am going to consider in this format. You can also do that. No, sir, I will not be using it. I'm going to use the another format, and what I'll do is I'll consider my y-axis at the top leftmost, and I'll consider it here. Yes, you can also do that. So based on how you are taking out your reference axis, these things are going to change. Let me rub this off. Okay. So this is what I did. I have taken out the centroid location at the center. Let me zoom in onto that location so that it is going to be easier for you. How I have followed it, how I have taken it out. This is what I did. So this entire triangular portion, the centroid is going to be located at a height of h by 3 from the base. Base under AB, ABC triangle. So it is going to be located at a height of h by 3, which is 40 divided by 3. Okay. I don't need to find out any x bar in this. I just need to find out the y bar, because it is symmetrical about y axis. Why should I bother? Unnecessary calculation ఎందుకు చేయాలి? Okay, so that is what I am going to be doing. And the another value for this semicircle, it is going to be located at a height of 4r by 3 pi from this diametrical end AB. So 4r by 3 pi from here. And I am going to make a detail about yi bar. which is 40 divided by 3 and 4r by 3 pi. Okay, the moments you are going to add up, and this is the value of yc that I have got. If you are getting any error in there, you are always welcome to inform me. Okay, hope you have made note. Same thing. So here what you are seeing, you are looking at ఇక్కడ మనకి ఇచ్చిన బెనిఫిట్ ఏంది అని అంటే they have not given any reference access. Same as in the previous problem also. So it is going to be your discretion, your understanding, your intellect, your common sense, your behavior, your attitude, your technology, whatever your decision. Based on your discretion, you can take out the location of that reference axis. Based on where you are considering your reference axis, things are going to get changed. Okay. So now you have this, there is a rectangle. To that top, you have a right angle triangle and you have removed a semicircle. మళ్ళీ చెప్తున్నాను, you have a rectangle, you have a triangle and you have a semicircle. So we have taken out the reference axis here. We have taken out the reference axis here. Then you have the rectangle O, okay, OCDF, which is of 80 by 30, and its xi bar is going to be a half of 40, and the yi bar is going to be 30 lo half, which is going to be 50. You can multiply these two to get the ai xi bar and ai yi bar. Triangle is there, which is again you are going to add it up. So half into 30 into 80, that is its area. It is reference axis is on this end, so it is located at a distance of 2/3 from the base. Sorry, 2/3 from the apex. 2/3 from the apex. So 2 by 3 times of 80. That gives me the xi bar. Yi bar is going to be 30 plus 30 divided by 3. So that is going to be 40 mm. Multiplication. And you are removing this semicircle. So minus a3 pi r square divided by 2. That gives me the area. And it's located at 40 plus 40 divided by 2, and this height is going to be 4r by 3 pi, so 4 into 20 divided by 3 pi, so multiplication part. So summation of ai into xi bar, summation of ai into yi bar, total area, capital A. Adding up all of them, you are going to get the location of xc as summation ai bar xi bar divided by a, and yc is equals to summation of ai into yi bar divided by a, and that gives me the xc and yc values respectively. Another problem in the same format. To a rectangle, you have added a semicircle and you have removed a triangle. So semicircle is added, rectangle is added, and triangle is removed. So semicircle, rectangle, and triangle, you are going to add them up, algebraic sum, so that you are going to minus this out. You are going to get this value. Since it is symmetrical about x-axis, I need to find out the x bar value. That's it. I don't need to find out the y bar value. ఒకవేళ if you are going to say that no sir, why should I follow you in your footsteps, I want to practice, you can take out your reference axis like this, the way that I have drawn just now. You can also take your reference axis in this format and you can do the calculations. Things are going to change accordingly. Like I have mentioned earlier, based on where your reference axis are, based on what procedure that you are following, things are going to change in the same pattern. Okay, so that is all about the finding out the areas for composite areas. Okay, let me deal with one thing. Uh, okay, let me pause here for a while. Let me pause here for a while so that you can make note. Then we will move on to the moment of inertia. Okay, yeah. So that's what we have seen so far, and this is what we will be learning in this part now. the area moment of inertia definition, what is meant by the moment of inertia term, how that term came into picture, what is the definition of it. There are some other terms related to it. As you can see, the parallel and perpendicular axis theorems, moment of inertia of the composite areas. So in order to go for the composite areas, first we need to calculate the for the basic areas. So that these things we are going to discuss first. Okay. So first, what the centroid is a area property and center of gravity is a solid property. Centroid is where your entire area is going to be acting. Center of gravity is where your entire body weight or body mass is going to be acting. We have learned from the basic principles how you are going to define or how you are going to determine the location of centroid of a plane figure and a composite figure just now. Okay. Now, uh, what you will be following is centroid is nothing but the area which is defined by considering the first moment of an area. So sometimes what happens is this first moment of area is not going to be sufficient for us. అంటే ఇంతకు ముందు నేను మీకు చెప్పేటప్పుడు I explained to you about axis of symmetry. There I mentioned about the first moment of area is going to be it can be zero sometimes. So if first moment of area is going to be becoming zero, that is going to be a difficult task for me. So what they have come up with is ఇప్పుడు a into plus x and a into minus x, these two are going to be getting nullified. If I am going to make one more multiplication, a into x multiplied with x, so that gives me ax square, and then here a into minus of x whole square. So what that gives me positive value. So that is what they come up with, saying that the second moment of area is going to be useful to us. So how is it going to be in the form? It is going to be in this form. So integral over the area x square into dA, and then integral over the area y square into dA, where x or y are what we are going to call with the name of moment arm, and this term that you are seeing, integral over the area x square into dA, is what is called as moment of inertia of the area, or area moment of inertia. I repeat, moment of inertia of the area or area moment of inertia. In general, moment of inertia and anna kuda, the same name can be applied as moment of inertia of the area also. Now, it is nothing but the second moment of area of the plane area. How you are going to calculate it? So it is this is the small area that I am considering dA, which is located at a distances of x and y from the reference axis. Now the second moment of area can be taken as y square into dA. If I am going to apply the integration for the entire area, so about x axis I am taking, so Ixx is going to be a y square. Okay, y square into dA over the total area. And then second moment of area with respect to y axis, perpendicular distance is x, so that is Iyy is equals to integral over the area x square into dA. Good. Integral over the area x square into dA. I am pausing in between. I am expecting that you are making note. So second moment of area of the plane area, ఇక్కడ క్వశ్చన్ ఏంటంటే, in an analogy to the centroid, whole area may be concentrated at a point kx comma ky to give the second moment of area for a given reference axis. Okay, so if I am going to keep the total area at this location, which is located at a distance of kx and ky from the reference axis, that is equivalent to the Ixx and Iyy values that I have calculated earlier. So that is what you call with the name of ky square and kx square. So these kx square and ky square are what called as radii of gyration. If it is 1, we are going to call it with the name of radius of gyration. Here you are looking at 2, so you are calling them with the name of radii of gyration. So, okay, this point will have a position that depends not only on the shape of the area but also on the position of the reference axis. Okay. Now, product of product of area of the plane area. So product of inertia, that's what we can say. Previous case, what has happened? You are looking at the moment of inertia. So you are multiplying dA, elemental area dA multiplied with y or x. Then you are multiplying it again with respect to the same distance value. So y into dA and on the ante y square into dA is what you are doing. So y into dA into y. So that gives me y square dA. Here what you are doing is, if you want to find out the relation of that area with respect to both the reference axis, then we are going to use up this one, which is Ixy is equals to integral over the area x into y into dA. I repeat, x into y into dA. So if your reference axis is going to be located something like this, so that is where my y is and here is where my x is going to be. So in this case, you can expect to get, suppose, and here is where I am considering my dA. So x in this case is going to be negative value. This is my x and that is going to be negative value, but y is going to be positive value only. Okay. So what is happening here is, this is what you are getting. Okay. So yeah. So this is what you are getting, which is nothing but the uh, integral over the area x into y into dA. Integral over the area x into y into dA. Okay. So that's what you call with the name of product of inertia. Product of inertia. Now this can be negative, like I have explained just now. The product of inertia about its axis of symmetry is always going to be equals to 0. అంటే యాక్సిస్ ఆఫ్ సిమెట్రీ తోటి తీసుకున్నప్పుడు మైనస్ ప్లస్ రెండు ఉంటాయి కాబట్టి దట్ ఈస్ గోయింగ్ టు బికమ్ 0. నెక్స్ట్ యూ హ్యావ్ ద ట్రాన్స్ఫర్ థీరమ్స్. ద పాయింట్ ఈస్ I need to know about how I can utilize these opportunities. Okay. So with the help of the transfer theorems, we can find the second moment of area, which is moment of inertia, and product of area, which is product of inertia, about any axis in terms of second moment, and the product of area about a parallel set of axes going through the centroid of the area. And I know the centroidal moment of inertia, I want to transfer it to the other location. And the effect, I want to know it on the other axis, towards the other axis. Or I know the moment of inertia about the other axis, I want to know the centroidal moment of inertia. In such cases, we are going to use these transfer theorems. These transfer theorems are going to help us in identifying such cases. Hope you are understanding the reason why I am pausing in middle. So the first one, very important one, state and prove parallel axis theorem. Okay, first look at the theorem. You can pause the video, or I'll give a pause here, just a 30 seconds or 1 second, 1 minute of gap. Okay, so the point here is the moment of inertia of an area about any axis in the plane of an area is equal to the sum of the moment of inertia about the parallel centroidal axis. Repeat, parallel centroidal axis, and the product of area multiplied with the square of the distance between two parallel axes. So by looking at the figure, I know the moment of inertia about its centroidal axis. I want to know the moment of inertia about this axis, which is AB. So how I can get that? It is nothing but IgG whatever I am getting plus area multiplied with whatever the parallel distance in between those two is there, that I am going to take. which is going to be yc square. This is how it is. IAB is taken as IgG plus A multiplied with yc square. So what you are doing, basically you are converting it from this location to this location. Okay, how, sir? How can I know? So this is how we will be performing. The distance between these two axes is yc. The A is nothing but the total area. Igg is the moment of inertia of this area given with respect to the centroidal gg axis. Okay, so these are the three terms. Now what I am doing is, initially I am considering a small elemental strip here. First let me give a pause here. Please do make note. Pause the video and do make note. Now looking at the elemental parallel strip of the area of dA at the centroidal, which is located at a distance of y from the centroidal axis. Now the moment of this second moment of area, so dA multiplied with y plus yc whole square, that's what we will be doing. Summation or integration y plus yc whole square dA. So integration alane untundi, y plus yc whole square, if I am going to expand it, y square plus 2yyc plus yc square. So integral y square dA plus integral 2yyc dA plus integral yc square dA. Now there are three terms in here. So if you look closely, y square dA is moment of inertia, yc is a constant value, y is going to be a variable. అర్థం చేసుకోండి, y is a variable but yc is not. Yc is a constant value. So integration లో నుంచి yc square is going to come out summation of the total area. So it is nothing but the capital A yc square. That's what this term is going to come up. And this term is going to be 2 into y into dA. First moment of area about its centroidal axis. Then you have the integration y square dA. So that is going to be ay square. That is what the I value that we have been seeing. So integral y square dA is going to be moment of inertia about the centroidal axis, and this term is a constant, and this is what you are going to get. The total area is this second term that you are seeing, it is going to become 0. Then the third term is going to be the total area multiplied with yc square. So that gives me IAB is equals to IgG plus A multiplied with yc square. Okay, A multiplied with yc square. So that is the proof related to it. In the similar fashion, state and prove the perpendicular axis theorem. దీంట్లో ఏమంటాడు అని అంటే, there is a set of axes x and y already available to me. I know the moment of inertia about those two axes, but if I have another axis which is perpendicular to these two, it can be found out by using the summation of, okay, summation of the moment of inertia about this axis and this axis together. So that gives me the moment of inertia about the z axis, which is perpendicular to the plane, screen, paper, whatever board you can take the name. Okay, so the moment of inertia of an area about an axis perpendicular to its plane is equal to the sum of the moment of inertia about two mutually perpendicular axes through the same point and lying in the same plane of the area. So Izz is taken as Ixx plus Iyy. How? So the distance I am considering it as r. So dA into r square. Okay, integration r square dA. Integration r square is nothing but, from the right angle triangle I can say it is nothing but x square plus y square dA. Okay, so integral x square dA plus integral y square dA. So that gives me, this is going to be Ixx, this is going to be Iyy. So Izz is equals to Ixx plus Iyy. Pretty much easier. Easy to understand, easy to identify, easy to take the theorem also, proof. Now comes the finding out the moment of inertia and product of inertia for the basic figures. You are already aware of this figure, so I am not going to say much of this. So you have an area like this, you have considered an area like this. And what you are asked to do is you are asked to find out the moment of inertia about the centroidal axis. By default, we know that the centroidal axis is located in this format. So let me go ahead in the simple format. So dA is nothing but B multiplied with dy. Okay, dA is nothing but B multiplied with dy. So when I am talking about Ixx of this elemental area, that is going to be equals to, okay, y square into dA, y square into dA. If I am using it for the overall area, y is going to be varying from minus d by 2 to plus d by 2. Okay, so minus d divided by 2 to plus d divided by 2. So how I can write it? So that gives me is equals to integral over the area minus d by 2 to plus d by 2 y square multiplied with d value is b into dy. Okay, so b is a constant value, it is not changing. So that gives me after integration b multiplied with y cube divided by 3, which is having the limits from minus d by 2 to plus d by 2. Okay, so that gives me what? B divided by 3, b divided by 3 multiplied with, okay, d cube divided by 8, d cube divided by 8, minus of minus plus d cube divided by 8. So that gives me what? D cube divided by 4 multiplied with b divided by 3. That gives me a total value of bd cube divided by 12. Let me rub this up. So that's what you are going to get. Similarly, if you are taking it in the vice versa, you are going to get it as db cube divided by 12. No change, no other change. If you are considering it for the y axis. So the only change that is going to happen in that case is you are going to get a small strip like this. And you are going to follow the same process. Okay. And let me rub off this. Okay. The next one. Similarly, if you are trying to go for the finding out the moment of inertia of the triangle about the base. Okay, so you are considering a small strip of B1 and dy, which is located at a distance of y from the base. And the area of the elemental strip is going to be B1 multiplied with dy. We know the value of B1, which is 1 minus b divided by y into h, or so, h minus y by h into b. Okay, that is going to be B1. The moment of inertia of this strip about AB is going to be this value. The moment of inertia of the triangle about AB is going to be of this format. IA is equals to integral 0 to h y square into h minus y by h into b into dy. And once you perform the limits on the integration, this is what you are going to get. bh cube divided by 12. Now, if I want to find out the moment of inertia about the centroidal horizontal axis, we all know that it's going to be located at a distance of how much? H divided by 3, correct? Okay, h by 3 from the base. Now, we know that from the parallel axis theorem, IAB can be written as IGG or IXX, okay, you can give any name, plus A into h divided by 3 whole square, because that is the distance in between those two. Now, IAB value is known to me, which is BH cube divided by 12, BH cube divided by 12 is equals to IGG plus BH divided by 2 into h square divided by 9. So that gives me BH cube divided by 18. BH cube divided by 18. So 1 by 18 minus 1 by 12, that gives me 1 divided by 36. So IgG is going to be BH cube divided by 36. So the moment of inertia of the centroidal triangle about its centroidal axis, moment of inertia of the triangle about its centroidal axis, horizontal centroidal axis in this case, it is going to be BH cube divided by 36. Okay, so that is the change that we will be following. Similarly, for the circle, for the circle about its diametrical axis. So again, we are taking out a small area. So dA is going to be r d theta into dr. We are going to take out its moment, y square dA r sin theta whole square into r into d theta into dr. Okay, then followed by moment of inertia of the circle about the x axis. We are simply applying all the required details. Y square into dA, దానికి limits apply చేస్తాం 0 to r, 0 to capital R for the r value, and theta value is going to be 0 to 2 pi. So that gives me this value, and that is how we are getting the value of pi r to the power of 4 divided by 4. So that gives me the Ixx is nothing but pi d to the power of 4 divided by 64 in terms of diameter. Remember, BD cube divided by 12, DB cube divided by 12, BH cube divided by 36, pi d to the power of 4 divided by 64. These are the values that are going to haunt you for the rest of your life in the coming next 2 to 3 subjects. Any shape that you are considering, any name that you are considering, they are going to be used for the analysis, design, and all the other cases. So please do make sure that you are understanding, right understanding, and you are remembering these things for the rest of your BTech period. Now, using the semicircle, for the semicircle parallel to centroidal axis, which is parallel to the diametrical axis. So this is how it is. So by default, what you will be doing is pi d to the power of 4 divided by 128 and 64 divided by 2. That's what you are doing. One ఏదైతే ఇంతకు ముందు మనకు వచ్చిందో దాంట్లో half, because the area is getting half. Area is getting halved. That's the only change, nothing else. 0 to r ఉంటుంది, but angle is not going to be 0 to 2 pi, but the angle is going to be 0 to pi. So that is how you are going to get the pi d to the power of 4 divided by 128. Okay, so I know about this diametrical axis. So what I will be doing is, it is located at a distance of 2d by 3 pi from here, which is 4r by 3 pi, using the parallel axis theorem. You remember how I did this in the triangular portion. So that gives me this value for the IgG for centroidal axis parallel to the diameter for a semicircle. Okay. Similarly, if you are talking about the quadrant, indulo half outundi, that is going to be half. I am giving a pause, you can make now. Okay. Now, the moment of inertia of the composite shape as shown in the figure, if you are asked to draw a similar shape and you are asked to find out its moment of inertia, remember, first understand about what they are asking. In this question, they are asking for the centroidal x and y axis. So first I need to locate this centroid. For that, remember the x and y table that I have told you earlier. So first we need to calculate this part. There are two rectangles over there. So this one, which is 15 by 5, 75, and then this one 25 by 5. This is number 1 and this is number 2. So two triangles areas are calculated, then x values. So the location of these coordinates from both the reference axis x and y, not the xx and yy, but ox and oy. So those values we have calculated, you just multiplied them, you got the summation values, because these two areas are getting added up. you are going to get the x bar and y bar values the way you can identify the location of the centroidal axis. Now I need to identify this moment of inertia about this axis. So I need to transfer from this to this. And let me draw it here. So for this rectangle, excuse me, for this rectangle that you are seeing, the centroidal axis for that is going to be located somewhere here. Okay, somewhere here the centroidal axis are going to be located. What you need to do from this axis, you need to transfer it onto this axis. From this axis, you need to transfer it onto this axis. So for that, I need to know the distance. I need to know this distance, how much is this, and I need to know how much is this distance. This is the centroid of this particular box, which is of 15 by 5. So I know that this is going to be 25 mm. I need to find out the other part. So that way I can easily find out. So how? Let us have a look at it. Sorry, first let me clear up the write up that I have given here. Yeah. So how? For the first part. For the first part. So I am not going to speak anything in here. I want you to understand and I want you to make note also at the same time. About its own centroidal axis. Then you are using the transfer theorem. This is the area multiplied with excuse me, area multiplied with h square. Next one, about its own centroidal axis. Then you are adding up both of them. And similarly, you are also going to transfer this and you are going to add them both. You are going to add them both. Similarly, for the y axis, this is what you are going to get. And then you are going to add both of them. Okay. So similarly, the second moment of area or moment of inertia, about its centroidal x-axis, the same one. So you can see that it is symmetrical about y-axis. I just need to find out its y bar so that I know the location of that centroid. So for that, first we need to find out the location of the centroid. So since they have already given out the names, reference axis లో ఒకటి నాకు తెలిసిపోతుంది. I will not be doing much effect. So that is how I am going to get my y bar. Once I got my y bar, using it, I am trying to find out the moment of inertia of this rectangle one about the xg and xg. So that gives me bd cube divided by 12, which is for this one 100 into 10 cube divided by 12 plus area is going to be 100 into 10 and 65 minus 44.24. So centroidal axis is going to be lying somewhere here. Centroidal axis is going to be lying somewhere here. So you need to draw the separate axis for all of these individually. Then only you will be able to understand them. Next, similarly, the moment of inertia of the rectangle 2 about this xg. So this is how it is going to be. So I know these two values. The third one, add up all these three, you will get the final value. That's it. Question lo kuda, since they have asked only about the centroidal x-axis, it is easy. If it is about centroidal y-axis, since y-axis the entire object is symmetrical, since the entire object is symmetrical, you are not going to get any transfer theorems to be applied in this case. You will not be applying any transfer theorems for this. You will simply adding up all those things. You will simply be adding up all those things. So db cube divided by 12 for this rectangle, db cube divided by 12 for this rectangle, and db cube divided by 12 for this rectangle. Okay, how do you might be wondering how you got this 44.24 ikkadenduku by minus ki right hand side ochindi, ikkadenduku minus ki left hand side ochindi అని అంటే, the reason is the location of the centroid for area 1, if you recall, it is located at a distance of 65 mm from this base. ఓకే. సో, 65 ఇక్కడ నుంచి ఉంది. సెంట్రాయిడ్ ఇక్కడెక్కడో ఉంది. సో, 65కి ఈ వాల్యూని మైనస్ చేశాను. అండ్ హౌ డిడ్ ఐ ఫైండ్ ఔట్ ద లొకేషన్ ఆఫ్ దిస్ సెంట్రాయిడ్? ఫ్రమ్ ద బేస్ ఐ ఫౌండ్ ఔట్. సో, దట్ ఈస్ హౌ దీస్ థింగ్స్ ఆర్ గోయింగ్ టు బి ప్రెటీ మచ్ క్రిటికల్ వెన్ యూ ఆర్ కాలిక్యులేటింగ్. ఎక్కడి నుంచి, ఎందుకు, ఏ విధంగా కాలిక్యులేట్ చేశాము అనేది యూ షుడ్ బి నోయింగ్ ఇట్. Okay, so this is the total moment of inertia of the area about xg axis. So the centroidal xx axis. All right. Now let us move on to the next one. So what is happening in here? In the mundu dantlo moodu add ayini. Now what is happening here is you have a rectangle. To this rectangle you have a semicircle which is getting added, and semicircle to part there is a circle portion which is being removed. So the moment of inertia of the shaded area about base AA as shown in the figure below. So they are asking us to find out the moment of inertia about this base. దీని సెంట్రాయిడల్ నాకు తెలుసు, దీని సెంట్రాయిడల్ నాకు తెలుసు, సెమీ సర్కిల్ సెంట్రాయిడల్ నాకు తెలుసు. సో ఐ నీడ్ టు ట్రాన్స్ఫర్ ఆల్ ఆఫ్ దీస్ టువర్డ్స్ దిస్ AA యాక్సిస్. Pretty much easier. But first I need to find out the centroid of that whole figure, so that once I know the centroid's location, I am going to apply this. So the moment of inertia of the semicircle about the centroidal axis for the area 1, area 2 which is semicircle, and then area 3. మూడింటికి మూడు వస్తాయి. So BD cube divided by 12 plus A into D square or AH square or AYC square, you can give any name, where this D square is nothing but this distance. అంటే దీని సెంట్రాయిడ్ నుంచి టోటల్ సెంట్రాయిడ్కి ఉన్నటువంటి లొకేషన్. ఓకే. And semicircle also the same way. So this part is this value you need to remember. There is no other go. You need to remember this value, and pi d square divided by 4 is the value for area of a circle. We are dealing with a semicircle here, so it is going to be pi d square divided by 8, where d is nothing but 200. So remember, ఇక్కడ ఇది ఫిగర్ చదివేటప్పుడు అర్థం చేసుకోండి. The inner circle which has been cut out is of 50 centimeters radius, whereas the outside one, it is of the radius of 100 centimeters. And what are the units for moment of inertia? Area multiplied with the distance square, ay square. I repeat, ay square. So centimeter square multiplied with centimeter square. So centimeter to the power of 4. First moment of area, ax, centimeter cube. Second moment of area or moment of inertia, centimeter to the power of 4. So once you got the third one also going to be calculated. So ఇది మైనస్ అవుతుంది కాబట్టి we are taking it as a -1, and that is going to give me the overall area of this entire figure. Okay, so you can pause it at the moment and you can make note. You can pause it at the moment and you can make note. Then in the similar portion, finding out the composite area. So you have a trapezium, అందులో నుంచి ఒక semicircle has been removed. So there are various ways that you can do this problem. Number one, you can create a rectangle of 60 mm by 60 plus 30 plus 30. So 30 plus 60, 90, 90 plus 30, 120, 120 mm wide and 60 mm height. So that is the rectangular dimensions. From this rectangle, three portions are getting removed, two triangles and one semicircle. That way you can do, or you can deal with it in the another sense. So you can draw a trapezium. You need to find out the location of centroid for the trapezium. Out of it, you need to find out, you need to minus out the semicircular portion, and then you need to calculate it once again. So it is all depends on how you are taking it. So what I am doing is, I'm taking out a rectangle. From that rectangle, uh, so like I have mentioned, three portions I am removing them, and using the same principle, the table, I'm going to get the location of y bar. Once I know the y bar value, moment of inertia of that entire rectangular portion about its centroidal axis, this is what I am going to get. Okay, this is what I am going to get, which is BD cube divided by 12, 120 into 60 cube divided by 12, plus 120 into 60 is its area. The centroid of this is going to be located at a height of 30 mm, and from the observation I can say that it is a symmetrical about y-axis. The point here is, the y bar is going to be different for both the cases, so 35 and 30. So that value is going to be coming in here, and this is how I got the moment of inertia about the centroidal axis. Similarly, for the semicircle also you can find out, and you just need to add up these two algebraically to get the required moment of inertia about the centroidal axis. Okay, number 3, number 4, number 1, number 2. So four parts are there. అన్నింటినీ కలిపితే you are going to get the moment of inertia of the composite area. Good. Now same thing. So here also you can follow in the same passion. So big rectangle nunchi one small rectangle and two triangles are being removed. So one, two, three, four, four parts are being removed. So you are going to follow the same passion, same procedure to get the required value. Okay. So this completes up the second unit, sorry, the first year mid portion. Please do make sure that first you are calculating the center of gravity or centroid. మీరు centroid find out చేస్తే you are going to get 5 marks in the third unit question. And after that, based on what you are calculating, it is going to change. Okay. So I'm going to pause this. Please do make sure that you are listening to this video on the right time. Thank you.